Welcome to my channel. If you are new for this channel, please subscribe, share, and hit the bell icon so you will going to get notified when I post new contents on Java programming. At the end of this lesson, we're going to learn object-oriented programming, advantages of object-oriented programming. We will see the history of Java and we'll see editing, compiling a Java program. So stay with me till the end of the video. Let's see object-oriented language. An object-oriented programming data and its behavior are bounded with a single entity which is called an object. In the procedure object-oriented programming language, data and its behavior are separate, whereas in the object-oriented language, data and its behavior, or we can say its activities, are bounded together with a single entity which is called an object. So let's see the advantages of object-oriented programming. The first one, they are simple. They model real objects through objects, so complexity is reduced and the program structure is somehow very clear. The other, modularity, each object forms a separate entity with whose internal workings are decoupled from other parts of the systems. Right here, every object will going to have its own copy of variable, so it makes somehow modular because its internal working principles are decoupled within the objects which are instantiated from that class. The other, modifiability, it's easy to make minor changes in data representation. It's extensibility, adding new features or responding to the changing operating environment can be solved by introducing a few new objects and modifying some existing ones. The other, reusability, objects can be reused in different programs. So Java was developed in the year 1995 at Sun Microsystem by James Gosling. It was developed based on the concept of write once and run anywhere. So the idea is the same. Software should run on different kind of computers and consumer gadgets on other devices. So having the JVM enable it to write one and run anywhere. So JVM generates bytecode as a result of compilation. They are a form of instruction understood by the Java virtual machine. That's why it has based upon the concept of write once and run anywhere. So every device having the JVM can run any bytecode, right? So it inherits the syntax from the C programming. It inherits the object-oriented principle from the C++ programming. So Java programs are basically two types. The first, they are application. They are designed to run on the local system and do not need any web browser to execute. In the applet, they work over the internet and are executed in Java-enabled web browsers. They run in Internet Explorer, Mozilla Firefox, Google Chrome, and others. So we can develop applets with a Java program. So right here, we don't have a Java source code. We have a Java source code right here, and we have a Java compiler. And the output of the Java compiler is Java bytecode, so it can be recognized by a JVM, Java virtual machine. And this generated bytecode can run on Windows, it can run on Linux machine, and it can run on Solaris Windows, and it can run on the Mac operating system. That's why that having a JVM will enable us to run generated bytecode. So what makes Java most powerful language? It's simple. It was designed to be easy for the professional programmer to learn and use effects. What makes it somehow simple is that it inherits syntax from C programming, and it inherits an object-oriented principle from the C++. So everyone having certain familiarity with those languages we're going to understand this language easily. Security, when we use a Java compatible web browser, we can safely download the Java applet without fear of any viral infection or any malicious intent. The other, portability. Since the JVM generates a bytecode upon compilation, that bytecode instruction can operate in any platform having JVM. So if you don't have machines having a different operating system, if you don't have JVM, it can the bytecode generated after compilation can run on different machine. The other, robust. It has comprehensive exception handling, strong type checking, and automatic model management and compiler check. So that makes it somehow robust. It has comprehensive set of exception handling that can withstand with a certain runtime errors. The other multi-thread, it supports multi-thread programming, which allows us to write programs that do many things simultaneously. So let's see editing, compiling a Java program. Let's see editing, compiling a Java program. The first phase is writing a source code or writing a source program. The next phase is compiling, because the computer cannot understand the source program, which is written by the high-level programming language directly. So we need to compile it. So compiler, we're going to change the high-level source code to the corresponding bytecode, actually, in case of Java program. So we're going to have a Java bytecode. The third one is loading a program. That bytecode should have to be loaded into the main memory. And the other, the phase 4 will be bytecode verification. It involves examining the bytecode to ensure that they are valid and not violate Java security restrictions. The other phase 5 will be the final, its execution. So the JVM executes the program's bytecode and thus performing the actions specified by the programmer. So these are the phase. First phase, writing a source code. Second phase, compiling a program. Third phase, loading a program. Phase 4, bytecode verification. Phase 5, execution. Right here, writing and compiling going to be done by the user, and the rest will going to be done by the rest, which means loading a program and bytecode verification is going to be done automatically by the JVM. So the user will going to write a source program, we're going to compile it through certain compilers, and finally execution or running the bytecode which is generated by the JVM. So here is editing, compiling a Java program. Right here, to compile a Java program, first we have to set the path of JDK installation folder in setting the environment variables. So we will going to use the command javac, then file name.java. For example, right here we don't have hello.java program in our desktop, so we're going to open the command prompt in the desktop, javac and hello.java. Hello is the file name and use Java extension. After running this command, we're going to have class file, which is a bytecode. So to run a Java program, we use Java, then file name. For example, right here, Java and hello. So it will going to display what's written there in the standard output. So hello there is the result. So this is how we're going to compile a Java program. So command prompt. If you don't have any comments and any suggestion, feel free to mention in the comment. So thanks for staying with me till the end of the video. Have a nice time.